All right. So it looks like the first video went well. So here's my second video. And for this second video, I've decided to focus on number 5 from the Unit 6 exam review. 1, because a lot of people requested it, and 2, it is a very good AP question, as well as I think one of the more trickier problems in the entire study guide, so I think it was a good idea to cover this one as well. So let's get to it. So fish enter a lake at a rate modeled by the function e given by e of t. All right, so first and foremost, we got to make sure we know the information that's given to us and highlight some of the key words that are going to be useful for us as we solve this problem. So first and foremost, we're told that fish enter a lake at a rate. Okay, so at a rate. So E is a rate. E of t is a rate. Fish leave the lake at a rate modeled by the function L given by L of t. All right. So fish leave the lake at a rate. So L is also a rate, but this time for how the fish are leaving the lake. Both E of t and L of t are measured in fish per hour. That should be another good indication that those are rates of change. And t is measured in hours since midnight. So t is equal to 0. So probably something to focus on. That t is hours after midnight. All right, so let's get to the first problem here. So the first problem is how many fish entered the lake over the 5-hour period from midnight, t is equal to 0, to 5 a.m., t is equal to 5. Give your answer to the nearest whole number. Set up but do not solve the expression that would provide the solution to this question. So first, and this applies to B as well, I ask you guys to just set up this problem because going forward, as you'll see, the setup we haven't discussed in class actually how to solve an expression that you'll eventually get to in a problem like A and B. We will get to this in class. Maybe I'll post a video, we'll see. But in terms of solving it, you just use a calculator. But in terms of setting it up, you can easily do that by hand, no calculator needed. So we're just going to focus on just being able to set up the expression in parts A and B. So we're asked how many fish enter the lake. So keyword here is enter. So enter the lake. Well, we're given two functions in number 5, E and L. Now, E of t, we're told, is a rate for how fish enter the lake. So we should probably focus on that. So a rate for how fish enter the lake. But we're trying to figure out how many fish actually enter the lake, not the rate at which fish enter the lake. So one way to think about this is since E is already our rate, so E is already our rate. But we want to find how many fish have actually entered the lake. Now, for some of you, this can seem pretty obvious. For some, I'm going to try to explain this the best I can. Well, let's think about this. If E of t is how many fish, is the rate at which fish enter the lake, well, if we were to take the antiderivative of this, so if we were to take the antiderivative of E of t, so if we were to take the antiderivative of E of t, we have to think of, well, what does that function represent? And we'll just call it big F. We'll just call it big F. Well, if E of t is the rate of fish entering the lake, the antiderivative is going to represent how many fish have entered the lake at any given time. So how many fish have entered? Okay? And that's the main or the key idea in a problem like this. The fact that if you're given the rate, but you want to find how much, in this case, how many fish have entered the lake, you want to take the integral of said function. So you want to take the integral of said function. So at this point, what we're going to do is we're going to take the integral of E of t. So we got that part down already. And we're told we want to find how many fish enter the lake from midnight to 5 a.m. So it actually tells us the t-value, so 0 to 5. And that's going to be your setup. That's going to be your setup. So you're taking the integral of e of t from 0 to 5. And that's going to give us our answer. And once again, we're not going to talk about solving this because at this point I have not covered in class how to do so. But that would be your setup. That is all you would have to do to get credit for a question like this. Just set it up, boom, you're done. Now, obviously, in an AP exam situation, you would be asked to solve this. So 1 point would be the setup. 1 point would actually be solving and getting the answer and answering the question. So that's A. So now let's go to B. So B is asking, what is the total number of fish in the lake at 5 a.m.? So set up but do not solve. So once again, we're just setting this up. We're not solving anything. All right. So let's think about this. So in the previous problem, part A, we talked about how if we took the integral of e of t, that gave us how many fish enter Now, if we use the same idea for the other function, so the other function is defined as the rate at which fish leave the lake. So if we use the same idea, let's take the integral of that. Let's take the integral of that function. So L of t. Well, if that is the rate at which fish leave the lake, the antiderivative should tell us how many fish leave. So the antiderivative should tell us how many fish leave. Well, why is that significant? Well, let's think about this from a logical point of view. If we know how many fish enter and we know how many fish leave, if we want to find how many fish are in the lake, what we're going to do is we're simply, if you subtract these two, it gives you how many fish are in the lake. Okay? How many fish are in the lake? Okay, so if you subtract these two quantities, it's going to give you how many fish are in the lake, right? So for example, let's say you knew that 5 fish entered the lake. But then at the same time, you knew 3 fish left. Well, simple math tells us that there should be 2 fish left in the lake. So it's the same principle here, right? You're taking how many fish enter the lake and you're subtracting that by how many fish leave. So at this point, if we're just taking the difference between these two expressions, our answer is just going to be the integral of e of t minus L of t. And that's going to be your setup. And we're still going to do it from 0 to 5. And that would how you would get credit for a question like this. Once again, we're not solving. If I had asked you to solve, at this point, you would literally just put this expression inside a calculator, you get an answer. Now, 2 things I want to point out. First, always remember, whenever you're working with integrals, make sure you always finish off the integral with a dt or a dx or whatever is appropriate to the problem. At the same time, another thing is you could also write this answer as 2 separate integrals. So you could also have written it as, if I write it here, you could have also written this as the integral of 0 to 5 e of t dt minus the integral of 0 to 5 L of t dt. That is also a perfectly acceptable answer because that follows from the property that if you take the integral of the difference of 2 functions, you can separate those 2 functions and just take the integral of them separately. So you could do that too. So that's part B. So now let's look at part C. So part C asks us now, is the rate of change in the number of fish in the lake increasing or decreasing at 5 a.m.? Explain your reasoning. All right. So at this point, a lot is going on here. And once again, this is a really good AP question, something that if you were to see it in a free response, I would not be shocked. So first, it's asking about increasing or decreasing. Now, if we go back to what we've talked about in class, so if we were to generalize this, right? If we were to generalize this, if we were to think back, when is so-and-so increasing and decreasing? So if we were to think about a very general question such as that, well, hopefully what comes to mind when you think of a question like this is, okay, we need to find this so-and-so's derivative. We need to find this so-and-so's derivative. So, right? So we have to find the derivative of this, whatever we're trying to figure out is increasing or decreasing. Well, let's see. What is this asking us to find is increasing or decreasing? It's asking us to find if the rate of change in the number of fish in the lake is increasing or decreasing. All right. So first, let's actually identify that. What is the rate of change in the number of fish in the lake? Well, in part B, we discussed the fact that if we want to find the number of fish in the lake, that's just the integral. Well, this question is asking us for the rate of change in the number of fish. Well, if the integral, right, if the integral of part B is the number of fish, the rate of change, remember, is just a fancy word for the derivative, would be the derivative. Would be the derivative of this expression. Let me just actually make this a little bit better. E of t minus L of t. All right? The derivative of this expression would be the rate of change. Well, hopefully this is another thing you remembered in class. If you take the derivative of an integral, you just end up with the original expression. So this gives us the rate of change for number of fish. Okay, so just that expression without any integral, just E of t minus L of t. All right, so we figured that out. So this is the expression that we want to worry about. This is the expression that we want to worry about. All right, now let's take this a step forward. Now it's asking us to find, is the rate of change increasing or decreasing? Well, once again, whenever we have a question that's asking us whether something is increasing or decreasing, we have to take its derivative. So let's take the derivative of this expression. Well, taking the derivative of this expression is pretty simple. The derivative of this is just going to be e prime of t minus L prime of t. Now you might be wondering, why am I not writing down these equations? Like, we know the equation of E of t, we know the equation of L of t. You can write them down, nothing wrong with that. I typically write down the functions because it's shorter, it's quicker, it saves you time, especially on the AP exam. You do want to see, you want to save as much time as possible, especially on those free response questions. So that's what we want to look at. We want to look at the derivative of this expression. So now it's asking us, is it increasing or decreasing at 5 a.m.? Well, if we know we have to look at the derivative, so we have the derivative, so we're done there. So we have to determine if it's increasing or decreasing. Now, remember, in order for it to be increasing, the derivative has to be positive, right? Positive means that it's increasing. Now, if the derivative is negative, right? Excuse me. So positive, it's increasing. If it's negative, it's decreasing. Well, it's asking us, is it increasing or decreasing at 5 a.m.? So we have to determine, is it positive or negative at 5 a.m.? Well, we've been told in previous problems that 5 a.m. means t is equal to 5. So all we have to do for this problem is check, is e prime of 5 minus L prime of 5 less than or greater, less than or greater than 0. So once again, if this is less than 0, means it's decreasing. If it's greater than 0, it means it's increasing. Now at this point, you would have to find the derivative of E of t, and you would have to find the derivative of L of t. Now this is a calculator question. I probably should have said that all you had to do was just set this up as well, because at this point, you could find the derivative of both these expressions by hand, But since this is a calculator question, I probably wouldn't do so. Even though it's not difficult, I think it's risky, and it's better than to just put an expression like this in a calculator. So at this point, I would just, let me get this here, put into calculator and just solve from there. So if it's less than 0, if that answer is less than 0, it's decreasing. If it's greater than 0, it's increasing. And once again, a calculator can find the derivative of a function. I will show you guys how to do that in the future. We actually got a new set of graphing calculators just recently. They're actually rentals. We're hoping that they will allow us to keep it. They're pretty fancy calculators. I would like to show them to you guys hopefully someday in the future, and I would actually like for you guys to use it on the AP exam. So the earlier I expose you guys to those calculators, the better. But for now, just know that this would be your setup. So what I highlighted in green would basically be what you would have to calculate. And from there, once again, if your answer is a negative number, it's decreasing. If it's a positive number, it's increasing. Once again, a very good AP question. All right. So now we look at D. So at what time is the greatest number of fish in the lake? Justify your answer. All right. So greatest number. Now I hope when you see a phrase like that, so greatest number, I hope you think about this idea of a max. That's one of those major topics that we talked about, finding the maximum or minimum of a function. Now, hopefully you remember that's related to finding, right? So finding the max of so-and-so, right? Going back to this idea of just generalizing the question. If you want to find the max of so-and-so, you have to find the derivative, right? You have to find the derivative. Well, let's talk about what this so-and-so is first. What are we trying to find the max of? Well, we're trying to find the max of the number of fish in the lake. Well, hopefully at this point you remember that in B, so part B, we discussed how you find the total number of fish in the lake. And we discussed that to find the total number of fish in the lake, what you have to do is you have to take the integral of E of t minus L of t, right? You have to take the integral of E of t minus L of t. So let's do that. Let's take the integral of E of t minus L of t. So that's our so-and-so, right? That's our function that we want to look at. So the integral of E of t minus L of t. Now it does give us an interval. Remember, we're not trying to find the number of fish in the lake. We're trying to find the max. So that's our so-and-so. Now, as I highlighted here, at this point, so that's our so-and-so, we want to find the derivative of this so-and-so. Well, we discussed in part C that we discussed in part C that if you take the derivative of an integral, so if you take the derivative of an integral, it just becomes that original expression. So that is the expression we want to look at, right? So if we take the derivative of an integral, you find that you just have the original expression. Okay, so we found the derivative. Great. So at this point, so we know we have to find the derivative. Oh, okay, we got that. At this point, remember, we have to find critical numbers. We got to find critical numbers because that's going to tell us where a maximum or a minimum could potentially occur. Now, once again, so we want to set this equal to 0. And at this point, we would use a calculator again. So we would simply plug this into a calculator and it would tell us when it would equal to 0. So it would give us some value. It would give us some value, question mark. And I'm pretty sure it only gives us one t value. It only gives us one t value where E of t minus L of t are equal to 0. So our next step is to determine, all right, is it a minimum or a max? Is it a minimum or a maximum here? Now, this problem, since we're given an interval, so let me highlight it here. Since we're given an interval, okay, at this point, all you have to do, since it's asking us just what is the greatest number of fish in the lake, all you have to do is you would have to test each of these t-values. You'd have to test each of these t-values, into the expression that gives us the number of fish. All right, so remember, just to review from part B, the expression that gives us the number of fish in the lake is the integral expression, right? It's just integral expression. The integral expression gives us the number of fish. So we would want to find the number of fish at this t-value. So we would do, where is it? Here we go. We would do the integral from 0 to whatever this question mark is of e of t minus L of t. So that is not the only t-value, though, you're going to test. You are also going to test the endpoints of your interval. So you will be testing 0 and 8 as well. So you will be testing the integral from 0 to 8 of e of t minus L of t. And then you will be testing the integral from 0 to 0, even though that's kind of redundant, of e of t minus L of t, mainly because if you recall, if you take the integral and your interval starts and stops at the same value, it's equal to 0. So that first one, hopefully is obvious, is equal to 0. Right, so this one just equals to 0. This gives us some value that we could just plug into a calculator, and this will give us another value. Now, out of these three values, one of these is going to give us the greatest number of fish. I believe it's the middle one. I would have to look at the solution guide again. But whichever number is biggest, so at this point, whichever is biggest or is largest is the t-value that you want. Is the t-value that corresponds to when the greatest number of fish is in the lake. So, as you can see, there are a lot of moving parts to this. There are a lot of moving parts to this. I hope I generalized it a little bit with the fact that I try to review a little bit this idea of when we find the maximum function, what do? We find the derivative, find the critical numbers. And then it's just keeping track of what function you plug in from there, right? Remember, it's asking us for the greatest number of fish in the lake. And that connects to part B, where we found that this integral function, right? This integral function tells us how many fish are in the lake, okay? So that's how we know we have to plug in those t-values into this integral. All right, everybody, that was number 5. Hopefully it made a little bit more sense. I know, obviously, I'm not going to be able to answer every single question that could pop up, but hopefully I covered a lot of it. Once again, this is the type of question I wouldn't be surprised to see on the AP exam. And at this point, I can tell you guys there's a very good chance that you can see it on tomorrow's summative. So like I said, hopefully this was another good video. Leave comments if you have any additional questions, maybe. Hopefully I can address them. Otherwise, I wish you guys a pleasant evening, and I will see you guys tomorrow. Bye-bye.